So good morning everyone, my name is Mark Jesse V. Resuello from NS1A3. So in this video, I'm going to show you the computation of UKC or underkill clearance and also the computation of the ship squat when navigating speed in deep and shallow water. So this is our sample problem. The ETA upon passing a critical place at Avon Mouth with a charted sounding of 5.0 meters was 11 hours and 45 minutes on 1st January 2015. So, if her calculated drop upon passing was 7.0 meters, so we need to solve for her UKC when passing the place. So, here's the tide table that we are going to use in this problem. So, the Avon Mouth, Port of Bristol, Thursday, 1st of January 2015. So, we have the time and height, 3 hours and 38 minutes, and the height is 10.7 meters. 10 hours and 31 minutes with a height of 3.8 meters, 16 hours and 8 minutes with a height of 10.8 meters, 23 hours and 9 minutes with a height of 3.6 meters. So, this is the next step. We will copy the 10 hours and 31 minutes and 16 hours and 8 minutes and their heights. And we also insert the 11:45 between them and the height will be x because we need to find the height of 11:45 hours. So next step is we need to find the difference between 10 hours and 31 minutes and 11 hours 45 minutes. So in our calculator, I will show you how to get the difference of them. So 10 degrees, 31 degrees, minus 11 degrees, and 45 degrees. And equal, and click again the degrees. So the answer will be 1.23 hours. So the next step is we need to find the difference between 10 hours and 31 minutes and 16 hours and 8 minutes and repeat the same process. So in our calculator, 10 degrees, 31 degrees, minus 16 degrees, 0.8 degrees, and equal, the answer is 5.61, or round up, it is equal to 5.62 hours. And next one, we need to find the difference between 3.8 and the x. So the answer will be x, and 3.8, difference between 3.8 and 10.8 meters, which is, the answer is 7 meters. So that is the differences of the time and the height. So after we find the differences in the time and height, we are now making a cross multiplication. So time and height, and the answer 1.23 hours, 5.62 hours, and then the height is x and 7 meters. So in this step, we need to perform a cross multiplication. So first step is we need to multiply 5.62 to x. So the answer will be 5.62 x. And next one is 1.23 multiplied by 7. So 1.23 multiplied by 7. So the answer is 8.61. So this is the product of the cross multiplication. So the next step is we need to transpose the 5.62x into the right side. So we will have the x equals to 8.61 and divided by 5.62. So we need to calculate it. So 8.61 over 5.62 is equal to 1.53. So, if we already got the product, we need to add the 3.8 meters. Why 3.8 meters? Because 3.8 meters to 10.8 meters is increasing. That's why we need to add 3.8. So 1.53 plus 3.8 is equal to 5.33. 33 meters. So this is the value or the height of the time 11 hours and 45 minutes. So next, in this part, we are now getting the UKC or underkill clearance. So the formula is UKC is equal to TW minus drop. So to get that, we need to insert the charted sounding, which is 5.0 meters. So we need to add the 5.33 and 5.0 meters, which is the total depth of water, 10.33. So the drop is the drop is 7 meters. So to get the UKC, we need to minus 10.33 meters and the 7 meters. So the answer will be 3.33 meters. So this is the UKC, the product of UKC. So after we solve the UKC or underkill clearance, and now we will proceed to solve the ship squat and the navigating at the given speed in deep shallow water. So the problem 2, we have solve the squat produced by a ship with block coefficient of 0.885 making good 10 knots. Solve for squat at deep and shallow water. So first, we need to solve the deep water. And we have the formula for deep water, which is squat is equal to BC or block coefficient times speed squared divided by 100. So now, after we get the formula, we need to substitute BC, which is 0.85 times 10 squared close divided by 100. So using our calculator, I will show you how to solve this. Open parenthesis 0.85 times 10 squared close divided by 100 equal. So the answer will be 0.85 meters. So, after we get the deep water, the next is we need to get the shallow water. So, this is the formula for shallow water. Squat is equal to squat in open water times 2. So, we need to substitute first. So, 0.85 times 2. So, 0.85 times 2 is equal to 1.70 meters. So, that is the answer for shallow water. So next, we are getting the calculated draft. First is for deep water draft. So, the given for deep water draft is equal to 7 meters plus 0.85 meters. So, if we add them, the answer will be 7.85 meters. So, next one is the shallow water draft. So, draft is equal to 7 meters plus 1.70. So, the answer for shallow water draft is 8.70 meters. So now, we will calculate the required time in passing critical place height of tide 6 meters. So just like we do on the first calculation, we have a tide table, but this time we are now looking for the time which is marked as an X. So first step is we need to find the difference between 10 hours and 31 minutes and X. So that will be marked as X. So next is the difference between 10 hours and 31 minutes and 16 hours and 8 minutes. So we need to put that in our calculator. 10 degrees, 31 degrees, minus 16 degrees, 08 degrees is equal, then click the degrees again. So the answer will be 5.61 or round up 5.62. hours. So after that time, we are now getting the difference in height. So 3.8 meters is from the time of 10 hours and 31 minutes. And the 6.0 meters is coming from the height of tide. And 10.8 meters is coming from 16 hours and 8 minutes. So we are now getting the difference in height. So 3.8 meters and 6.0 meters, the answer will be 2.2 meters. Next, we are now getting the difference between 3.8 meters and 10.8 meters, which is the answer will be 7 meters. So that is the answer for the differences in time and height. So now, after we get the differences, we are now making a cross multiplication between time and height. So first thing is we need to multiply 5.62 and 2.2 meters. So the answer will be 12.36. So next one is x multiplied by 7. So the answer will be 7x. So now, we have the product in the cross multiplication. The next step, we need to transpose it. So x is equal to 12.36 over 7. So we need to calculate it. 12.36 divided by 7. So the answer will be 1.76 or round up 1.77. hours. So, the 0.77 hours is more than 60. So, we need to multiply it by 60. 0.77 times 60. So, the answer will be 46. So, we are now have a 1 hour and 46 minutes. So now, we are in the last part. So, we need to add the 10 hours and 31 minutes plus 1 hour and 46 minutes. So, the answer will be 12 hours and 17 minutes. But, how we get the 17 minutes? First, we need to add 31 plus 46. So, the answer is 77. But 77 is more than 60. So, minus 60. So, the answer will be 17. And then, the 60 is equivalent to 1 hour. So, 1 plus 10 is 11 plus 1, 12. So, 12 hours and 17 minutes. So, the required time passing in critical place of height of tide in 6 meters will be 12 hours and 17 minutes. So, we are now done in calculating UKC or under keel clearance and the ship's squat when navigating at the given speed in deep and shallow water. So, I hope you learned something. Thank you for listening. Again, I am Resuello Mark Jesse from NS1A3.